missing today, and I totally forgot this. We are recording Tuesday, October 6th, third period geometry. We are on page 60. We are looking at the line with points R, S, T, U, V, W, and X on them, and we are doing problem number 20 that says if TW equals 81, so we're looking at T to W on our line is 81, and VW is 35, so we find V to W is 35. They want us to find TV, the measure of TV. So we notice that V is the betweenness point. So Zach did the math very quickly, and he said, is the measure of TV 46? And it is, isn't it? Because
we subtracted, that's pretty incredible.
We subtracted 81 minus 35, and we got 46. Now, that's not the point in geometry, so to speak. Pardon the pun. The point is, we find the answer, but we have to come to court and tell the court why it's guilty of being 46 beyond a reasonable doubt.
You have to say why you got that.
You can't just say, well, it looks like it. I've got a client here, they're guilty. They look like it. Put them in jail.
In our case, it feels like it.
It feels like it. They're guilty of it. Put them in jail. That doesn't work.
You got to be way more specific.
You have to prove it beyond a reasonable doubt.
You have to be way more specific.
And so you're being given lots of definitions and statements, postulates, and theorems to help you state those in proof format to say, well, the reason why TV is simply 46 is this.
The definition of betweenness.
The definition of betweenness gets it all started. And you just don't say definition of betweenness. You need to lay out the equation that it would look like using the points, right? So you would say VW plus TV has to equal TW. Is that right? When you look at from T to W, you've got TV and VW coming together to create those, don't you?
Yeah.
So that's what you're going to write out. So braille out TW, or excuse me, TV plus VW equals TW.
Equals what?
TV equals
VW equals TW.
Oh, I thought you said Tico. I was like, what?
Yeah. Here.
So on your number line, you double check that. You're like, all right, TV plus VW is going to equal the entire.
Look at your line. Line T and V.
Right?
It's a 46-inch flat screen.
Okay, and then find VW.
And I see a line here.
So Zach,
can you agree that the measurement of TV and the measurement of VW will equal TW?
Yeah, because T and W are right here.
Yeah, good. Yep.
Hello?
So physically,
that's all she's saying.
In a graphic or in a tactile, it's showing that points by point, right? It's saying from point T to V and then V to W, those combine to make the entire TW, don't they?
Yep.
And that point of betweenness is what point?
V.
V. Right. The point of betweenness is V. So when we want to write it out as an equation or a formula, we're going to write out each segment. TV plus VW equals TW. Okay?
What? It's not plus trois equals trois?
So You tell the court that. You say, Judge, TV plus VW equals PW. And the reason why I get to say that
is you're the
because
teacher.
of the definition of betweenness. Right, Naramar.
And you also get to say it because you're the teacher.
Yes and no. So, Zach, I'm going to ask you to kind of turn on the respect card and responsibility card today, and I want to get a little serious with this, all right?
I am serious, but...
Okay,
yeah.
Thanks. So, we get to write this. We just don't write it. Now we have to say why we got to write it down.
Yeah.
And we're going to write underneath this definition of betweenness.
Yeah.
Okay?
There we go.
So that's where it all gets...
Definition of betweenness.
Yeah, so you can abbreviate definition DEF, period. Of, right?
Okay.
Yeah. Isn't there a short form for between?
Well, it's a low adult H.
Yeah.
Yeah.
So that's where it gets started, doesn't it?
Yeah.
Now,
Earlier, hold on.
the next step, the next list, the next logical reason is now we take a look at that equation, and instead of having all those letters, we try to get rid of as many of them as we can by the information we were given. So we weren't given TV, were we? We were told we got to find that. So we got to rewrite TV again. So we say TV plus.
TV.
Yeah, hold on.
Okay.
I had to
And
write
then
out between this.
we look back at our formula, our equation, and it was VW. Did they give us information for VW?
Yeah, I mean, they gave it here.
Yeah, they said VW is what?
They said, hold on.
Find it.
It would be under the number line, number 20.
Number 20. Mm-hmm.
VW, they said it was 35.
They said it was 35. So instead of writing VW again, we're going to write 35.
Yeah.
So we're going to plug in 35.
35. What a glorious number.
Right. So we're going to say equals. And then from our original formula equation from definition of betweenness, it said equals the TW, right? And so we go back and we look and say, well, what did they give us for TW, the measurement of TW?
81.
81. So we're going to plug in 81. Okay. Now, we have to give a reason why we just did that. Why were we allowed to take those letters and replace them with numbers?
Because of substitution.
Substitution, yes, Naramar. The substitution property. Now, you can't abbreviate substitution because it would get confused with subtraction. So you have to write substitution all the way out, but you can abbreviate property, PROP. All right. Now you look at what you have and you're like, okay, now I've got a simple one-step algebraic equation.
Yeah.
We have TV plus 35 equals 81, don't we?
Yep.
Now TV is just the measure of TV, point T to V. It's not a T and a V that we're trying to find. It's just an unknown as like a box sitting there. We just want to try to figure out TV. So we treat TV as just a variable all together as one thing.
Makes sense. Yeah.
So it's plus 35 equals 81.
And it's not T times V.
No, it's not T times V.
Because I've learned it in algebra.
Mm-hmm.
We should write like an algebraic equation.
Yes.
A lot of times if you write, like say you had A, B or something like that, then it would be A times B.
Yes.
But that's not always the case, but that's...
No. Not. So in geometry land, when we have capital T, capital V together in geometry land, that just means the measure of the segment TV.
Yeah.
Okay? So it's just one thing together. It's not T times V. So we're just hanging out looking at this one thing, TV, plus 35 equals 81. So how are we going to show the court? How are we going to show our work? What needs to happen next? How are we going to get the answer for TV by showing our work?
Well, we have to do the math.
We have to do the math. What kind of math do we have to do?
Let's see.
Solve the problem up here.
Yes. What do you want to do to solve the problem, Maze?
Subtract TV.
Close. We want to get TV by itself.
Subtract 35.
Yeah, subtract 35 from both sides.
Yeah.
So in the next line, you're going to show that. TV plus 35 minus 35 equals 81 minus 35.
Whoops.
What's that?
I'm sorry, that was my phone.
An army horn?
All right.
That's my husband.
Hello, Mr. Peggy. All right, so we just showed that we are going to subtract 35 from both sides, so we can, as Maze said, we need to solve it, right? Why do we get to subtract 35 from both sides? What allows us to do that in math?
The subtraction property.
The subtraction property of equality, right? So you're going to say, you have to spell it out, subtraction, because we don't want to get that confused with substitution.
I thought it was the
Subtraction. You want to say prop, P-R-O.
Prop. What is this?
I thought it was the commutative property, JJ.
Commutative property says that we can add in any order. So 1 plus 2 is the same as 2 plus 1. Subtraction property says we can subtract the same thing from both sides and it will still be equivalent. Addition property says we can add the same thing to both sides and it'll still be equivalent. Multiplication property says we can multiply by the same thing on both sides and it'll still be equivalent. And division property says we can divide both sides by the same thing and it'll still be equivalent. So we use the subtraction property here. So that's what we tell the court. That's what that's the rule, that's the law that allows us to show you that we can do this. Then you do the math, right? And so we did the math. Zach already did it at the beginning. He said it's 46. So you write TV on your next line. TV equals 46.
46.
And there is a rule why we get to say that again.
The substitution.
The substitution property. Yep. Now we're telling substitute 46 for TV. Substitution property. And we're done.
Yay, in 2 days.
There is your proof as to why TV, the measure of TV, equals 46 on this particular line. So when you come to court, you're presenting this proof to the court. You're just saying, well, TV is guilty of 46. And the judge says, why? And you go, well, just because it is. And the judge says, get out of my court. We don't put somebody in jail just because they look like it, right? They look like they're guilty.
There has to be some reason.
We got to have the reasons beyond doubt. Okay, judge, I've got the reasons for you. Here are the reasons.
I
First,
think proving something in court is a lot easier than proving it in math court.
yes and no. You're good at this, it'll make you might decide you want to be a lawyer. So, most lawyers are extremely good at geometry.
Really?
So, yes.
Wow, I didn't even think about
So, you go, all right, judge, I was given the values that TW equals 81 and VW equals 35, and I had to find TV. And on my line, I looked at it, and V was my point between T and W. So I'm going to I'm going to explain to you this equation that VW plus TV equals TW.
that.
That should make sense, Judge, because I can add these two together because of the definition of betweenness. And the judge goes, okay, yeah, I follow you. That rule is in the book. I get you. Okay. All right, Judge. Now I'm going to explain to you that I can rewrite that as 35 plus TV equals 81. So I don't want those letters in there anymore. I'm using the substitution property to put the values in for the letters because I was given those. I was told that TW equals 81 and that VW equals 35. So I used the substitution property and I plugged those in. All right, Judge, are you following me? Yeah, I'm following you. It's all good. Substitution property is definitely, we use that all the time. All right, now the next line down, Judge, I have to subtract 35 from both sides because I want to isolate TV. I want to get TV by itself and tell you what it is. So because TV plus 35 equals 81, I got to get rid of that plus 35. So I'm going to subtract 35 to get rid of it. If I subtract 35 on one side of the equation, I got to subtract 35 on the other side of the equation. And the property that allows me to do that is
the subtraction
the
property.
subtraction property. That's right. And the judge goes, yeah, you're right. Subtraction property's in the books. That's right. That's exactly what you're allowed to do. All right, Judge, thank you very much. So I'm going to do a little bit of math, Judge. I'm going to subtract that 35 from both sides, and I'm going to write on my next line, I'm going to let you know that TV equals 46. And I get to say that because of the substitution property. So that, Judge, is why the measure of TV is 46 beyond a reasonable doubt. There's your proof.
Yay, proof.
All right? So, do 21.
20.
Take the next 10 minutes, 5 to 10 minutes right now on your own, and do number 21.
But JJ...
And you can help each other.
I'm joking with you, Jay.
In the world.
You can help each other if you want to, or you can do it all on your own. But you need to do number 21 right now. We're going to go over it, and
44.5.
when you're finished, which hopefully will be in 5 to 10 minutes.
Ooh, decimals, fancy.
I didn't
use your
expect a decimal.
resources. You can use calculators if you want. It's not about the answer. I want the answer. But in court, beyond a reasonable doubt, why is it the answer?
True, true. Let's find out. Now let's write down the points.
Hello, Mr. Peggy.
Sorry.
I think I'm supposed to subtract.
Okay, so you do this problem just exactly the same way you did the last one, right? And you have to have the properties of what you're doing each time.
Not in there.
Oh, okay. So what do you have written down?
The numbers. Like, I know you can use substitution for numbers.
Okay, so what's your basic equation? Start with just the letters first.
Fine.
That's what I got. JJ's writing it down, and I'm just making sure that I write it down.
There we go, JJ.
I heard you brailing away, Zach, and your document camera is not on your brailer right now.
Oh. Yeah, remove that.
Says if SW equals 44.5 and SW equals 37.1, find VW.
Correct. And so what we need to do is to come up with an equation. That's gonna help us define VW, right?
Well, the top one is what we did, and the bottom one down here is what I did.
Look at the
I
line.
would use your own mixed.
Find SW and SB and
How do you feel about
BW.
it, Zach?
Huh?
How do you feel about
What
it?
can you use to write an equation?
I understand it, but having a little trouble writing it down in steps.
Okay. All right.
Yeah, me too.
I get all the steps, but I don't know what order to put them in.
Okay. So try to use something like the peanut butter and jelly analogy. Peanut butter and jelly sandwich analogy. You can't spread peanut butter and jelly on something until you have the something, right?
Yeah.
So the very first step is always, where do you need to start? What's the bread, right? So the bread is that equation. You typically start with the equation that represents the definition of betweenness. So what would that be?
The equation, let's see, hold on, I'm just fixing my watch real quick. Just adjusting the band so it's not too tight. And I'll read the paper. Oh, there we go.
That's W, only I'm not sure.
I think the equation, SW equals 44.5 and SV equals 37.1 finds VW.
Yep. So what are you going to write down as your original equation?
SW equals 44.5.
Okay, so that's not an equation. That's just the givens. That's what they're telling you. But now you need to put out the equation like x plus y equals z, right?
Yeah.
So you got to do, what are you going to put together What are you going to add together to equal the whole?
You mean subtract?
Well, that's how we're going to solve it in a step below, but what
44.5 plus 37.1?
No.
Darn it! I've got to turn that off.
S plus.
So what is when you look at the drawing, what is your betweenness point?
Wait, where's there the drawing? I don't see.
It's the same line we've been using.
Oh, okay.
Right?
Okay.
So we have SW equals 44.5 and SV equals 37.1. Find VW.
I think it's SB.
So
The betweenness point.
The betweenness point?
Mm-hmm.
Think what's between? It's.
Go ahead and say it, Naramar.
It's V.
It's V.
The betweenness point is V.
Oh.
V, right? So we have to say from S to V plus from V to W is going to equal SW.
SW, yeah.
You have to state that first. That's the bread.
Yeah.
Right? SV plus VW equals SW.
Yeah.
So did you get that written down?
I had it and I was going on to the numbers and it was
good.
apparently wrong.
Wait,
No, it was
SW.
great. Did you
S-
know
Write down the numbers.
SV plus
Oh, excuse me.
VW
Why did I do that?
Yep.
SV
plus
plus
VW
equals
equals
SW.
SW.
So then
And-
you substitute in the numbers where you can. So what does that look like?
Like I was thinking SV plus.
equals SW.
See, I wasn't even sure what equation to put in there.
All right, so that's okay. I'm getting some good feedback here.
Yeah.
Maria, you were not, and so was Zach. And Naramar was kind of like, he's able to figure it out on
Yeah.
the graph, but not
Yeah.
quite how to write it down. So let's practice that, okay? That's my job as a teacher, to realize that all three of you, that's where we're getting a
Yeah.
little lost. So let's practice that. So
Yeah.
let's just stop there and talk about how you can figure out what that equation is. So you need to use your line that they give you in your book, and you have to use the measurements that they give you also with the letters. You're focusing on the letters right now, but eventually we're going to need the numbers to use our substitution property. So we notice that on 21 they say SW, right? So you go to your drawing and you find S and W.
Yep.
Okay, there's S and W. And I notice when Naramar does that, he just goes up and he uses his fingers. He has stretchy enough piano fingers.
Yep, I do play
that he
piano.
spreads his fingers between S and W, and he notices tactily, okay, they're from S to W is 44.5. Then they tell you that from S to V is 37.1. So when you find S and V, you're like, okay, that's 37.1, and you notice that V is the between point, isn't it?
Yeah.
It's the between point between S and W.
Yep.
So just using your drawing, you can create the equation without even thinking about the numbers. You can go, oh, if I take SV and I add it to VW, that's going to equal SW, isn't it? So
Does that make sense?
use your drawing to help you. Use your tactile to help you.
Yeah.
So then you just, explore it, right? This is our E of EPSI. So there is our equation. SV plus VW equals SW. So we're going to write that down. SV plus VW equals SW.
I just put down SW. SV plus SW equals.
Uh-oh. So we need S
SB plus V.
plus VW equals SW.
Yeah. Okay. So your drawing can help you. Okay. Now, I want to stop there. That's your first step, and you would say definition of betweenness. That gets us all started. I heard you saying, all three of you were like, oh gosh, I struggle with that. Let's try another one.
What's going on?
Oh, you're out of paper.
Let's back up and
That white paper seems to be working for you.
try
Awesome.
number, or I'm just going to give you one. Let's look at your number line again, and I want you to write an equation from what I'm going to give you. So R to U, I'm just making
I'm in a good piece of paper.
is 22. You find RU on your number line, on your tablet. Everybody got it?
Okay. Hold on.
You don't even care about the numbers. You just read that RU is 22. So you find RU on your number line, on your number line.
Yeah. RU 22.
RU is 22.
That's a rhyme.
Yep. And then you're told RS is 8. So you find RS.
Hey, look
All
how
right.
far my fingers stretch.
Yep. Okay. So RU is 22, RS is 8. What would you write for your equation?
Let's see.
RS plus RW equals SW.
RS plus SW. I was saying U.
Oh.
RS plus SU
Yeah, that's what I meant.
equals RU. That's right, Maria. Yep. RS plus SU equals RU. There you go. That's your equation for definition of betweenness. On the information I just gave you, you don't care about the numbers right now, right? You're just trying to figure out where am I on my line and how am I going to represent that as an equation, as a formula, so that I can say definition of betweenness. Let's try it again. Look at the same line, and I'm going to give you a measure of Tx,
Text.
and I'm not even going to tell you what it is. Tx is blah blah.
Okay.
Tx is blah blah, and
What?
Ux is blah blah.
What measurement is blah blah?
Find the measure of Tu. What's your equation going to look
TX
like?
plus UX.
Careful.
No, excuse me.
Tx is blah blah, Ux is blah blah. Find the measure of Tu.
Careful, look at the graphic. The point of betweenness.
So first you find T and X,
X.
then find U and X. What's your betweenness point?
V.
U.
U.
Or U,
U.
sorry.
So we're going to have to say from T to U plus
Oh, you're right, okay.
U to X
T to U and U to X.
is going to equal
TX.
TX. Right.
What?
You confused?
I thought you were supposed to add the like TX and UX.
No, because TX is
Is the whole
the
segment.
whole segment, and you need to add up two segments by finding the letter that's in the middle. Does that make sense?
TX and UX, U's in the middle, but how?
So U's in the middle, so you want the segment from TU and the segment from UX to equal TX. Because you want the two you're putting the two line segment, you're adding them together to get the whole segment.
So TU plus UX equals TX.
Correct.
Hey, yep. TU plus UX equals TX. What do you notice about that when you're writing that equation? Do you notice any pattern? TU plus UX equals TX.
Well, that just repeats, I guess.
What
That's the only
repeats?
thing I've noticed.
He does.
The U repeats, doesn't it? Do you notice that when you write out the equation, the U is repeating itself?
No, I'm looking at it.
Isn't it?
Yeah.
It's the betweenness point.
Yeah.
It's what they share, isn't it?
But the betweenness is what the two things share. So it's like that's going to be next to the plus sign on either side of the plus sign.
Oh.
Does that make sense?
When we did the last one, we wrote RS plus SU equals RU, didn't we?
So the point of betweenness is on either side of the plus sign.
It's between it, isn't it?
Yeah.
And then the outside are the length, the whole thing, right?
Mm-hmm.
The T and the X and the R and the U.
Mm-hmm.
Okay. All right. So there's your equation for definition of betweenness on that one. Let's try another one. Go back to your line. RT equals 5,348,595. Doesn't really matter, right? RT equals a crazy number. RS equals another crazy number. What is the value of ST?
All right.
So how are you going to write your equation? So
we first got to figure out the point of betweenness.
all right, what's your point of betweenness?
S.
S. Good, Maria. Okay. So how would you set up your equation of betweenness?
RS.
Mm-hmm.
S plus RT equals.
Remember that point of betweenness is going to be
Oh,
either
RS plus.
RS plus SE equals
or ST.
Yes.
something like that.
Say it again,
Equals
Marimar.
RT.
RS.
Whatever it is.
I'm sorry that you're frustrated.
RS plus ST equals RT.
RS plus.
I think it's on either side of the.
Yeah, with a flip of the tongue.
That's all right.
So directly from the number line is your equation. The
Mhm.
R to the S is the first one, plus the S to the T is the second one.
Yeah.
To equal
RT.
RT, the outside.
RD.
Yeah. Zach, how you doing?
It's 11:12.
It is
What?
11:12. Oh my gosh.
You gotta be kidding me.
All right. We're having so much fun.
I wasn't even watching the freaking time.
Right.
But I've been watching it. I mean, listening to it. I can't watch it.
All
We
right.
gotta get going. I didn't even.
We'll review and warm up tomorrow with doing this and then writing another simple proof for it.
Oh my gosh. I did not freaking
And
think.
then we'll move on to congruent segments and
Oh boy.
how
glad.
we can use our definition of midpoint
Midpoint.
and our congruency theorems to prove that two segments are equal to each other.
Okay.
Cool.
Mm.
I wonder what's for lunch. I hope it's something good.
See you tomorrow.
All right, see you tomorrow. Y'all did good thinking. This is hard work.
Yeah.
And you're going to laugh at yourself in March or April when you're like, remember when we just did proofs that were about the definition of betweenness? And you're going to be doing 12 to 15 line proofs to prove a couple of triangles equal each other.
Yay.
All right, have a good day.
You too.
Yeah.
Bye-bye.
Crap. I should have been watching this.